Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. A hurricane policy covers both water damage, X, and wind damage, Y, where X and Y have joint density function equal to 0.13 e to the minus 0.5x minus 0.2y minus 0.06 e to the minus x minus 0.2y minus 0.06 e to the minus 0.5x minus 0.4y plus 0.12 e to the minus x minus 0.4y for positive x and positive y and 0 otherwise. Calculate the standard deviation of x. And here's a solution. For positive x, we calculate the density of x as the integral over all possible values of y of the joint density where it's positive. So from 0 to plus infinity with respect to y. And that's the integral of 0.13 e to the minus 0.5x minus 0.2y minus 0.06 times e to the minus x minus 0.2y minus 0.06 e to the minus 0.5x minus 0.4y plus 0.12 e to the minus x minus 0.4y. And now what we do is we notice that we need to take the integral with respect to y, and this expression, well, we have four exponential expressions. So look at the first one first. E to the minus 0.5x minus 0.2y. That's really e to the minus 0.5x times e to the minus 0.2y. We're doing the integral with respect to y, so the expression e to the minus 0.5x is just the constant, so is 0.13 with respect to y. So we could put it in front of the integral. And for the next expression, we could put negative 0.06 times e to the minus x also in front. But then e to the minus y is common to both of them, so we can combine those terms and simply have the first two terms equal to 0.13 e to the minus 0.5x minus 0.06 e to the minus x, the whole quantity multiplied. My apologies. My dog Chesterton started barking, so I'm very sorry about this. So this whole quantity is multiplied by the integral from 0 to plus infinity of e to the minus 0.2y. But that is, of course, the mean of exponential distribution with hazard rate 0.2, because e to the minus 0.2y is the survival function of that exponential distribution with hazard rate 0.2. And then, for the second pair of expressions, we have 0.12 e to the minus x minus 0.06 e to the minus 0.5x multiplied by a common integral from 0 to plus infinity of e to the minus 0.4y dy. And that's the integral of the survival function of exponential distribution with hazard rate 0.4. So it's the mean of that distribution, which is, of course, the reciprocal of the hazard rate. So what we get is 0.2 times 0.13 times e to the minus 0.5x minus 0.06 e to the minus x plus 1 over 0.4 times 0.12 e to the minus x minus 0.06 e to the minus 0.5x. So we multiply it all out and we get 0.65 e to the minus 0.5x minus 0.3 e to the minus x plus 0.3 e to the minus x minus 0.15 e to the minus 0.5x. And this simplifies to 0.5 e to the minus 0.5x, and the density is 0 otherwise. This is the density of exponential distribution with hazard rate 0.5. So x has that distribution, The mean is the reciprocal of the hazard rate, so it's 2. 1 over 0.5 is 2. The variance is the square of the mean, so it's 4. And the standard deviation is the square root of that square, so it is equal to the mean, and it's 2. And that's answer B. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in new studies and good luck on the test.